So, when working with Pearson's correlation, we calculate what's called, or rather, SPSS will calculate the correlation coefficient. We saw that long formula, which is R. However, the correlation coefficient by itself can actually be a little bit confusing as to what it represents with regards to our data. So we can actually take that correlation coefficient and translate it into a more intuitive measure of practical significance. And the way that we would do that is by calculating what's called the coefficient of determination, which is represented by this R squared. And so if you're looking at R squared, comparing it to R, and noticing that the real, the only difference between there is the squared, value, then you are correct. So in order to calculate a coefficient of determination, we would take our correlation coefficient, whatever we calculated for that, and then we would square it. So multiply it by itself and turn that into a percentage by multiplying by 100 or moving the decimal two places to the right. So in behavioral statistics, we often deal with complex human behaviors that have multiple influences. And so R squared allows us to help our readers understand the importance of the relationship that we're studying by describing the relationship in terms of variable X has a, some percentage of impact on variable Y. So a curvilinear correlation. Not all relationships between X and Y necessarily form a straight line. In a curvilinear relationship, the relationship between X and Y may begin as positive, so both variables moving in the same direction at the same time, but becomes negative. And so at some point you'll see that those two variables will begin to move in opposite directions, such that one will continue increasing while the other decreases. But conversely, you could see that while the two variables are decreasing, because remember that also describes a positive relationship, at some point maybe the secondary variable might begin to then increase, and so we would see a negative relationship taking place. So degrees of freedom, as I mentioned, with all of our different tests, we are seeing how we have different degrees of freedom. For correlation, the formula for degrees of freedom is n minus 2, where n is your total number of cases. For creating your null and research hypotheses and concluding statements for your correlational tests, your null hypothesis would state that there is no relationship between the two variables in the population. And I included the notation here. This p-like symbol, please don't confuse this for p as in probability. It's actually a Greek letter called rho. And so this is representing the relationship between variables in a population, such that your null hypothesis is saying that there's no relationship, and where your research hypothesis is alternatively stating that there is a relationship between the two variables in the population. As you are being asked to produce null and research hypotheses, please make sure that you remember to incorporate the context from the research question. If I were asking you about the relationship between education and income, you would want to make sure that your null and research hypotheses are very explicitly identifying that for your null hypothesis, there is no relationship between education and income. For your research hypothesis, there is a relationship between education and income. For your concluding statement, you would be identifying, coming to the conclusion that there is or is not a relationship between variable 1 and variable 2. Therefore, we retain or reject the null hypothesis.